Welcome back to another video. Today we are going to prove that if a is an integer, then 3 divide a raised to the power of 3 minus a. Okay, how can we prove this? So we know that integers can be divided into odd number and even number, right? Okay, so if you start with a being odd, okay, and a being even number. Okay, here's what happened. So we're gonna have a, so there exists, let's say k, which is an integer, such that a equal to 2k plus 1, and you might exist k, which is an integer, such that a equal to 2k. Now what happened to a cubed minus a? It turns out to be 2k plus 1 cubed minus 2k plus 1. Now we try to show that this a must contain 3 as a factor. So we're gonna have ak cubed plus what? 3. Okay, give me a second. 3k square. Okay, 3k square plus 2k plus 1 minus 2k minus 1. Then it turns out to be 8k square plus 12k square, or 8k cubed, sorry. 8k cubed and 2k I cancel, 1 and 1 I cancel. So it turns out to be just like this, 8k square plus 2k square. There's no way to show that 3 is a factor of a cubed minus a. Now let's go to another case. When a is 2k or a is even, what happened to a cubed minus a? Equal 2k cubed minus 2k. It turns out to be 8k cubed minus 2k. And it is unable to factorize 3 out of this term. So I'm unable to show that this term a cubed minus a is a factor of 3. So when you start with a being odd or when a being even, you cannot prove this statement. So what can we do with this? We might have to increase the number in the front of k. Okay, this number in the front of k right now is 2. It may be 3, 4, 5, or 6. But I want to try the number in the front of k being 3. So the first thing that I want to do is to prove this. Let's start to prove it. So we let a be an integer. Okay, and we have to consider a and 3. Okay, consider a and 3, and then what do we have? Okay, so we will use the division algorithm. Okay, so by the division algorithm, what do we have? So there exists q, which is an integer, such that a equal to 3q. Okay, I forget to have r, sorry. The q and r, which are integer, such that a equal to 3q plus r, where r is greater than or equal to 0 and less than absolute value of 3, which is 3. So r can be 0, 1, and 2. Okay, r can be 0, 1, and 2. All right, so what do we have right here? we're gonna have A equal to 3Q, in the case where R is 0, or A equal to 3Q plus 1, or A equal to 3Q plus 2. Okay, 3Q plus 2. So now we have number 3 in the front of the quotient right now. So there will be 3 cases, right? There will be 3 cases. So we start with the first case, the case where A is 3Q. Okay, so we have to try to write A cubed minus A and try to factorize them with 3. So let's write A cubed minus A. It turns out to be 3Q cubed minus 3Q. Then it turns out to be 27Q cubed minus 3Q. And then we can factorize them with 3. So we're going to have 3 times 9Q cubed minus Q. Okay. So that's what we have. So now 3 is a factor of A cubed minus A. Okay. So we can show that in this case by divisibility, 3 divide A cubed minus A. Okay, next case. The case where A equal 3Q plus 1. What about this case? Okay. So we're going to have A cubed minus A equal A cubed plus 1 cubed minus 3Q plus 1. Then it turns out to be 27Q cubed, right? Plus 3Q squared, and plus 3Q plus 1 minus 3Q plus minus 1. Then it turns out to be, okay, let me write this one, 27Q cubed plus 27Q squared and plus 6Q. Okay, plus 1 minus 1 has gone, so we factorize them with 3. We're gonna have 3 times 9Q cubed plus 9Q squared plus 2Q. Okay, so then what do we have? We have 3, which is a factor of A cubed minus A. So by division algorithm, we're gonna have 3 divide A cubed minus A in this case again. Another case, the case where A equal to 3Q plus 2. Okay, 3Q plus 2, and then what do we have? We're gonna have A cubed minus A equal to 3Q plus 2Q minus 3Q plus 2. Okay, and then what do we have? We gotta have 3Q plus 2Q, right? So it turns out to be 3Q cubed plus 3 plus 3 times 3Q squared times 2 plus 3 times 3Q. Okay, and 2 squared plus 2Q minus 3Q minus 2. Then it turns out to be 27Q cubed plus, okay, 54Q squared, and 9 times 4 is 36Q plus 8 minus 3Q minus 2. Okay, and then what do we have? We're gonna have 27Q cubed plus 4 plus 54Q squared plus 33q plus 6. Okay. Then what do we have? Factorize number 3. So it turns out to be 3 9q cubed plus, okay, in this case, what's the number? Factorize number 3 out of this number, 18, okay? 18q squared plus 11q plus 2. This is an integer, right? And we have number 3 right here. That means that a cube minus a has a factor of 3. So we're gonna have 3 divide a cube minus a. Okay, that's what we have. Okay, so from all cases, 3 divide a cube minus a. All right, therefore how do I write? If a is an integer, then 3 divide a cube minus a. Okay, so this is how to use divisibility to prove this example. That's it for today, and see you in the next video.